And well, I guess it's time to move on. It's been too much time working with triangles, but section 8.4 continues. It deals with areas of triangles. And the good thing is that now we can find area of any triangle. We already saw this formula. So if there are sides A and B for our triangles, so if opposite angles also going to be A and B, then the third angle will be C. So if I know the measure of angle in two sides that surround it, then I can find area. Area, like that. Area of triangle, which is going to be 1/2 times base times height. But last time we noticed it's 1/2 times B. And then instead of height, I put A times sine of C. So instead of height, I can write A multiplied by sine of C. Why is that? So instead of height, it will be A times sine of C. Well, definition of sine that deals with right triangle. So it's hypotenuse here, which is going to be A. We have opposite side called H. So sine of angle C is a quotient of opposite over hypotenuse. And we can put the opposite side, which is H, and hypotenuse, which is A. And that way we can replace by what? Well, if I bring A side, so if I multiply both sides of this by A, I get A sine C is equal to the height, and that's exactly what I had replaced my height with here. The height H is same as A and sine of C, and B stays by itself. A, B, B, A, same thing. So technically, just the way we define sine as opposite over the hypotenuse is what is here. Thank you for being in the classroom. I'm collecting all that, and at the end of the day, we will discuss what this all brings you with, because I was asked last time to provide people with the final exam a little bit earlier, which is this coming next week, Thursday, so a week from today. It doesn't mean that I'm going to run the final so early, but for those students that want to take it early, I'll send it to the whole class and you decide. You want to take it early, you want to wait for another 2 weeks, fine with me. But you will have such an opportunity. And those people that in class presently won't have to take the final if they don't want to. Yes, if you want to, you say, Alex, I want to take the final. I don't mind, because I love grading and I can definitely give it to you and grade it. But if you feel like taking the time after Thanksgiving off and planning to leave a country for the Thanksgiving week, that's fine with me. So next week will be the last week, basically. And then Thanksgiving week, we'll have only Tuesday, because Thursday is Thanksgiving, right? So only Tuesday. So on Tuesday, I'll log in and talk to those people that want to take the final exam. But we'll discuss all that next week, okay? So far, I'm glad that you are in the classroom, and that's definitely going to pay. And again, you can decide. Some people might say, Alex, it's what about us? You said everybody can get a extra credit. Well, I was thinking about giving an opportunity to everyone not to take the final. If you're happy with your current grade, I'll let you not to take the final. Keep the current grade. If it's B, it's going to be your grade for the class. If you're fine with it, if it's A, then it'll be your grade for the class. But you need to submit me homework. Submit me with the homework. That's important. But those people that have more extra credit, maybe they can even skip on homework option. So we'll see. We'll decide. I need to look at it. So next week, I'll have a clear answer, so it'd be fair for everyone. So I think that'd be great. So if somebody wants to take the final anyways, say I didn't get in B, I want an A, well, sure, good idea, you can do that. So we'll discuss all that on Thursday, a week from today, and of course start next week on Tuesday. So anyways, let me do a problem. You will see that this is really nice formula, and the section is pretty straightforward, has short exercises, and the point of story is all you need is two sides and angle in between. They may be called A and B, or they may be called with some other letters. As long as you have angle in between of those two sides, then you can find area of triangle constructed on those sides right away. So let's try, say, problem number 13. So it's section 4 of this chapter. So exercise 13 has two sides, A and B. So B looks like 4, a little bit longer, and A is 3, and angle in between of those sides is 40 degrees. So pull it as C, and triangle is right here. So how to find its area? Well, use the formula above. 1/2 AB 3, 4, well, say BA you wrote, well, put 4 times 3, same thing. And the sine of 40 degrees, right? 40 degrees. And of course, the calculator is needed here, scientific calculator. Scientific, and let's get it. The 1/2 or 0.5, if you don't want to enter half, 3 times 4 or 12 times sine of 40 degrees. Make sure it's not radians because it'd be different result. Degrees. They gave you degrees. It's always clearly given, so I can round this, put 3.9 approximately square units, 3.9 of square units, right? Area, like that. And all problems here are pretty much the same. So I think I can do one more and move on to the next chapter, because they are really very similar. Let's say exercise number 17. Let me make a picture of what we have. Sides are A and C. Okay. A, which is 3, C, which is 2. And the angle is always going to be in between. It looks like this. Angle is more than 90 degrees. This is angle B, which is 110. Whatever. 110. Please notice it's always the same thing. Two sides, and angle must be in between. I say, what if it is not? Well, then you're going to need to try to solve triangle and find angle in between, but I don't think they're going to do this to you. Notice that A is across the side A and C is here. So in that location of B is there. So what do I do to find the area? Put word area, it's not A, it's area. Well, it has to be 1/2. And then we multiply those two sides. Let me write it down. So sides are, in our case, A and C, right? And then we have angle B. Okay, so sine of B. So notice that there must be three different letters. AC, then angle is B. Or BA, then angle is C. So there's always A, B, and C gonna be involved. So again, I put 0.5 times 3 times 2, and then I must use a calculator for the last one because it's sine of 110. So I think it's pretty straightforward section, right? Someone told me last time that the previous section was nice. I think this one will be even nicer, right? So 3 times 2 times sine of 110. And the trigonometry should not be too bad, because I know that experience of the previous chapters was not the best. And well, to be honest, I think the class should start with this chapters first, because that way it makes you feel much better, right? So 2.8. Okay, whatever it is. So areas of triangles, I guess that's favorite part of arithmetic classes. The base times height was, I think, first encountered in arithmetic classes. So I want to move to the next chapter, discuss a couple of sections. So today, just one. They're, I think, also very straightforward, but they're talking about very different story. The story that you probably never encountered before, the story that discusses how to describe our favorite rectangular plane, the XY plane, completely differently with respect to what you have been doing so far in all of math classes, where you used those Cartesian or Descartes coordinates, utilizing this XY plane, where you put two perpendicular axes, call them X and Y. So every point on that plane was described with its X and Y coordinates. And that's totally different with what description we're gonna get in the chapter, in the last chapter of this class. And I'm just waiting for it to open. So that's called chapter 9. So I wanted to look at first two sections of it, called polar coordinates. So forget about X and Y plane, and then pairs X and Y to describe points. Start with the center, or so-called pole, and then positive direction of x-axis. And then any point on this plane could be described completely differently, not with X and Y coordinates, but with distance to the pole. And that's what they call with a letter D here. Actually, they use letter R. I want to be consistent with the book. R. An angle that we have with this positive direction of x-axis, which is called theta. So if you put pair r and theta to describe the point, it's not the same as x and y, because first is angle, second is angle, so it has nothing to do with y coordinate, it's angle, and the first is a distance to the center. See, it's completely different distance. So we use absolutely different pair. So a resemblance with x and y is wrong. It's not really at all x and y. You say, why do we need that? Well, it turns out that for cases when you deal with circular functions, it's very convenient. It's much more convenient to deal with this polar coordinates when something is described using various rotations. Like, for example, if you start rotating things, and well, lots of times it happens in various physical kind of motions. If you're trying to see the wheel of the car when somebody drives and what's happening, what functions relate, there were points on it or their trajectories, and the same thing happens in physics with various particles, how they travel. So for particular applications, it is convenient. It's not always convenient, no, but it is convenient sometimes. And that's the point why trigonometry talks about this. So I'd like to move to the exercises and start to get used to these ideas, because they're quite different. And that's why I think it's a good idea to start today and to continue with these ideas next week on Tuesday. Shouldn't take too long, but still, we need to get used to this. So one not very pleasant fact to realize is that points on the polar plane have infinitely many descriptions, and that's inconvenience. So if I have a point, we already know that I can have the angle theta and the distance from the center as r, but it turns out that I could also, instead of using the same angle theta, I can rotate the opposite direction and produce exact same end point. So if I don't rotate by positive theta, but if I go from 2 pi, from full rotation, subtract theta. So if I don't go all the way around, but subtract theta, and same r will give me exactly the same point. How about that? Well, we can see that the point will be the same if I start here, go by r and then rotate by theta, or rotate opposite. I say, Alex, so you can even rotate it another time, another time, another time, or the other way around? Yes. So technically you can add period 2 pi times k, and you're still going to have same. Turns out it's helpful to describe four-dimensional functions. So when you have something that is being rotated, but through 3 dimensions, so it's on that level, and then you go up higher level, up higher level, up higher level. So you're not really repeating the same circle, but the next circle is on the higher level and the higher. So that's how people could imagine those four-dimensional things that we usually because we're three-dimensional species, not four, but that helps us to describe those things somehow. So we can add period 2 pi k, and k could be either positive or negative. So that way we get those kind of results. And here's another very amazing thing. The same exact point could be treated if your r is negative. Let's say, how come r can possibly be negative? Well, turns out it can. So if you, again, look at the direction here and the pole there, and if you get the same exact angle theta, but r is going to be negative, so it'll go in the opposite direction. So in order to get back to the point that we trying to describe, I need to take not angle theta, but add pi to it. So if I take angle theta, but rotated by pi, so negative r will bring me to the opposite side. And say, what did you say? Well, here's your theta. If you get pi added to it, which means it's going to be our angle by 180 bigger. So I actually have to land here, right? But since my r is negative, I'm not going to be here. I'm going to be on the opposite side of pole. And that'd be exactly the same point we described. So the point of story, r is not really a distance here. It also may be with negative sign, which means it's like opposite direction distance. And that's kind of odd thing. I would say this is worth to think about over the weekend because it's definitely different, right? And of course, there is a relationship with points on the plane xy with the points in the polar format. All you need to know is angle theta and radius r. So if you already know that y x coordinate is here and y coordinate is here, then how can I describe those x and y in terms of angle theta? And turns out that we already saw this, like in the previous section, the height was r times sine of theta, and similarly, the adjacent side will be r times cosine of theta. And that's the relationship between x and y coordinates and polar presentation. You say, are you sure? What are you talking about? Well, let me make a bigger picture. You will see it right away. So that's angle theta. That's opposite side to angle theta. It's always with respect to angle theta. And that's right triangle. So that's adjacent side. Adjacent side. And that's called hypotenuse, right? So adjacent side is x and opposite side is y.
Well, it is for 6 people there. Additional occupancy fees.
So it looks like we're going to get the y, the opposite, related to the hypotenuse. So how can I relate them? Function sine, right? So sine of theta is opposite over hypotenuse. And the cosine analogously is adjacent over hypotenuse, right? Cosine. Adjacent. So we're going to put our letters for hypotenuse, that's r, right? Remember, distance from pole, r. And for adjacent is x, so that's x over r. And analogously, for the sine, it's going to be y over r. So it's all here in front of us. You just need to not to hurry, sit down and write it out, and you will see these two formulas right away. And that's going to be very popular formulas in the future if you ever continue with math. So r, I go to the other side and multiply both sides of equation by r, so y is coming out as r times sine theta. And analogously, when I clear that denominator from here, I get r times cosine theta. So I just memorize these formulas because you will see it numerously, and you don't have to memorize anything for our class, right? You can just write it down. So let me do a few exercises and see how we can solve those. So I'll start with number 9. So it looks like, again, we are here in the new chapter, new section, and this section is 9.1, right? So 9.1. That's our last chapter. So exercise 9 is asking us to get the point in the polar form. So it's not xy. It's r equal to 2, and angle theta is equal to negative 11 pi over 6. So what I want to do is make a picture of that, because 12 pi over 6 is a full rotation, isn't it? So if I look at the circle, and the circle now will be radius 2 for a change. Why 2? Because r, the radius of the circle, is 2. Now I need to break this into over 6. So I have to put 1, 2, 3 here, 3 here. So 3 cuts, that's 2 cuts in this here. So it looks like negative 11 pi over 6 will go here, right? If I rotate like that, so it'd be negative 11 pi over 6. And the radius was 2, so we're still here. If it was negative 2, I would be on the opposite side. So here's the point that we produced. And this point could also be treated if I had same r equal to 2, but angle just pi over 6. If I went in the counterclockwise direction, as we usually used to, but it doesn't matter. Idea is it's still the same end result, still the same point, right? So got this picture. So what are we trying to do? See, it's either A, B, C, or D on the graph. Looks like it's A. Notice angle is pi over 6 and distance is 2. So it's point E. It looks like there are various possibilities here to end up with. It's interesting to start to get used to those pictures. So you can plot points like number 19 that may seem to be a bit confusing to some people, because again, those are in polar coordinates. That's important to realize. So we have negative 2 and 0, such as r and theta. So they don't have to give us a pair. That's confusing. I think they should have said r is negative 2, theta is 0. So that way will be more straightforward for us to decide. So what I do is I take angle theta, which is 0. So it goes along my positive direction. And now I need to put 2, but since it's negative, it'll be here. if that's my pole, then the point is here. In fact, we can even get its XY coordinates. What will be XY coordinates? Well, looks like X coordinate will be -2 and Y will be 0. And that's quite amazing because looks like in this case, polar coordinates are identical with XY Cartesian coordinates, but it's not always the case. It's just a coincidence happened, so no need to worry. I just want to make pictures. And I guess that's the most difficult part, at least it was in my case, to make that transition to start to treat the pairs differently than X and Y. But after a while, you get used to it. So let me try another one. Maybe I'll do one more and that should be good enough because I think I'm already overwhelming you. I already talked about one section and here comes another, and I know it's end of semester and I know we're in a good shape. So I'll do just 39 and that'd be enough for us. So find the rectangular coordinate in exercise 39. So I'm not going to even make any pictures here. I'll just write that R is 3 and theta is pi over 2, right? And I use the fact that we just saw here about X and Y. So X coordinate is R cosine of theta, definition. And Y coordinate is R times sine of theta. So I'm going to plug numbers in and get my answers. 3 times cosine of pi over 2 and 3 times sine of pi over 2. And that's it. We're done. We have those. Just put them in a calculator, or if you remember how to deal with 90 degrees angle, its coordinates are 0 for X and 1 for Y. So that's cosine. You still remember that? And then sine of that angle, pi over 2. Sorry, I shouldn't have put theta, it's pi over 2. So we can replace those in, right? Just need to put numbers instead of cosine 0, instead of sine 1, right? 0 and 1, and this will be 0 and this will be 3. So if you wish to make a picture on XY plane of that point, the coordinates for X will be 0, so we're on the Y-axis, and Y will be 3. So the point is right here, 0 and 3. So notice pair 3 and pi over 2 does not have much to do with this 0 and 3. How can you possibly relate it? You need to use formulas. So that's the idea. That's why don't be deceived that in this rarest case, the description R theta matched exactly description XY. It's not usually the case. So I think next week I will continue, we'll do some more of these and we'll start to graph those points and graph some of these little functions. That'd be the plan. So that'd be planned for Tuesday. Then before Thursday next week, I will send you a practice for the final exam. And we'll decide who takes it, who doesn't. Actually, you'll decide. And if you decide to take it, I will work out this practice final for you and everything. And This way we'll be prepared for it. So that'd be the plan, and you can actually see what be on it here. I have that, remember, YouTube channel. I gave you the link to it where all the lectures are. So I just wanna, I think it's wrong class. I wanna go to 135.
I believe that we actually
It's totally different. To playlists. I think I gave you a link to playlists as trigonometry. So we have here, that's not mine, it's advertising. So you can see on the playlist at the very end, I believe it should be lecture with the final review, like 20, I think one of these 24, I pulled them the wrong way, 25 probably. But anyways, you can locate it if you are interested in that, but we'll decide, we'll discuss that, so no worries. We will do this again, we will do this next week on, I'm not sure where I click over here, on Thursday next week. So then following Thanksgiving week, Tuesday, I can discuss that final in more details. So the following Tuesday after the Thanksgiving, I believe it'd be the 3rd of December, you will already have the final actually on hands, because I plan to email it to everyone on Tuesday, Thursday next week, but as I was asked. But on Tuesday, 3rd of December will officially be that final due, and I will be again logged into Zoom. So if you have any questions related to it, of course, I can help discuss it. And then you'll have more time. So it's like 2 weeks, basically, starting Thursday next week. So we'll have another week, Thursday, Thanksgiving, which we don't have a class, but the following week, Thursday, I'll also be on Zoom. So if there's still something unclear, I'll help. So I'm doing it in order to give people plenty of time, because practice showed that we had a number of students who needed more time for their midterm, and then they did pretty well in it. So I don't want to give worse grade because you're, I guess, having some other things going on. I know those are important things, right? That's why I can wait, no problem. All right, so I guess that'd be enough. And again, I'm glad that we had 3 people in classroom today. So I'm gonna stop this recording and wait to see if you have any questions. And if not,